And now that I have all of my important aspects of my data listed up here, I can use this to try to identify, are there any potential outliers based on the minimum and the maximum values we have? Well, let's see, Q1 minus 96.75, that's 132, minus 96.75. I think we're pretty safe there. I don't think there's anyone that weighed less than 37 pounds. Actual subtraction notes says 30. Okay. So on the low side, there's no one that had a weight of less than 35.25 pounds. Okay, because we know that the minimum value is 103. So no values fall below this. What about our Q3 plus the 96.75? Well, let's see. That's 196.5 plus 96.75, which, you know, figure that's 2. Checking my math there. I think it's close if it's not. Right? Okay. Well, our largest value is 227 pounds. So are there any values beyond the 293? No. Based on this collection of data here, we don't have any outliers. No potential outliers. Okay? All right? Well, let's suppose that someone very big came into class. So weighed 327 pounds, walked through the door, and I want to take your class. I wouldn't say no because they're much larger than I am. At least squash me. So now, with this new data value, would there be a potential outlier? Yes. Well, yeah, this extra 327 pound person does not fall within the range of what we would consider typical of the data that we were given. And so in this case, that person, this 327, would be considered a potential outlier. All right. Now, this collection of data, the information that I've written on the board here, is an important summary of the data that we have for the information that we were given on weights. These 5 numbers here tell us a lot about the distribution of data here. They don't tell us everything, but they do tell us a lot. These 5 numbers collectively are what are known as the 5-number summary. And collectively what they tell us is they tell us how spread out our data is, how much data we should look for in between varying ranges, and ultimately we can use this data to create another graphical display of our data. Okay? So the 5-number summary consists of the minimum value, quartile 1, the median, quartile 3, and the maximum value of our data. Using these, we can construct what's typically referred to as a box plot. Sometimes you'll also see it as a cat and whisker plot. And they have all sorts of different names for this thing. But it's just another way of visualizing how our data is spread out, or how it's distributed. Okay? When dealing with a box plot, what you're going to do is, the first thing you're going to do is you're going to work with the middle 3 numbers. You're going to work with Q1, the median, and Q3. Okay? And in terms of the picture, what you do is you start with a box. All right? Start with your box. The endpoints of your box represent Q1 and Q3 respectively. Okay? So the 2 vertical lines in your box are the first quartile and the third quartile. And again, you can make this as spread out as you want. You can make it as wide as you want, as long as you try to keep everything to scale with the rest of the picture that we're going to draw in. Okay. All right, so this is Q1 and this is Q3. I want the median. Well, I want the median to be representative of how close it is to Q1 and Q3 in terms of the differences between the data values. Right? So if I put my median over here, if I say this is my median, then what I'm saying is that my median value is much closer to Q1 than it is to Q3. Okay? In terms of my picture, again, 25% of my data is here, 25% here, and 25% is there. Okay? Now, the width of the box, the width of how much is in each of those regions is irrelevant to what percentage of my data is there. Okay? There's 25% of my data here. I don't care if the difference between the median and Q3 is 5,000 units. This picture is telling me that 25% of my data is between the median and Q3. And if that's 5,000 units, then so be it. There's a 5,000 unit difference between the median value and the third quartile value. Okay? When we go to look at sort of translating this picture into a different picture, we're going to utilize the fact that 25% is here and 25% is here. All right? Okay. Once we have our median found, we then go ahead and fill in the last parts of our box, our plot, and that means using little, what are often referred to as whiskers, coming out of our box. These lines here go out until they reach our minimum value on the low side and our maximum value on the high side. And again, this is just a reference. Again, the lengths of each of these pieces here is just a reference to the differences between, in this case, the Q3 value and the value of the maximum point. Okay? Again, 25% of our data is here. 25% of our data is here. Okay? All right. This is the box plot. Now, if we were to make a graph of this picture like we have with the other ones, actually, before we do that, can you identify the shape of this data without me having to draw any more picture? What would you describe this distribution shape as? Skewed. This picture should be representative of something that is skewed right. You'll notice that 50% of our data is compressed in a relatively small amount of, a small range of values. Okay? Small range of values there. Very, very large range of values for the upper 50%. Okay? So if we were to sort of graph this as a picture, what we should get would be something that looks similar to this picture right here. All right? Taking this and translating it into something like this. Again, one of those valuable tools. You can look at this picture and you can think about, well, large range of values down here, or on the upside, means that it's very spread out as I move towards the top end of my graph. All right? One final word to say about these box plots. If, for some reason, there are potential outliers, what you'll typically see, these potential outliers are often marked with X's on these graphs. Stars or X's or something like that. So for example, over here, I may have things like this. Okay? Again, this picture is indicating to me that there are 3 outliers on the top side of my graph. I might have the same thing on the low side, depending upon how the data is listed.